In this video, we are going to be talking about Newman projections and how to draw them correctly. So when you have carbon-carbon single bonds, they have the ability to rotate, giving them different possible conformations. And what a conformation means is basically the way that it is arranged three-dimensionally, and depending on how they are arranged, they will have different energy levels. And so what we really want is the lowest energy level possible because that would be the most stable. So when we draw Newman projections, we can get an idea about the three-dimensional conformation of that molecule, and we can observe differences in energy levels using those. So this video is going to be more about what it is and how to draw it, and then we will have more videos on conformational analysis, and that is where we're going to get into all of the different energy levels. So first of all, a Newman projection is a 90-degree rotation of a wedge and dash drawn. So you can see here that we have a simple wedge and dash, and we are going to be rotating it 90 degrees, and so that way we're looking straight on at this front carbon, and then the back carbon is going to be directly behind it. And so if you look over here, I have the two different pieces of a Newman projection that are superimposed on top of each other to make the entire Newman projection. So we have the front carbon, which is going to be right here, and then we have the atom that is attached to that front carbon that's in the plane going up, and then we have whatever is on the right here, that is going to be the atom that is coming out of the page at us, and then whatever is on the dash going behind the page is going to be on the left. And then we have the back carbon drawn as this big circle, and same thing, we have whatever is in the plane going straight down, whatever is on the wedge coming out at us is going to be on the right, and then whatever is dashed is going to be on the left. And then we just superimpose those, so this right here is going to be the front carbon, and this is going to be the back carbon. And I also color coordinated these to make it a little more obvious. We have all of the pink hydrogens coming off of this little dot right here showing the front carbon, and then all of the green hydrogens are coming off of this back circle showing that they are coming off of the back carbon. So how to draw a Newman projection. I always look from the left side at the front carbon like this. And so the first thing we need to identify is the front carbon and the three groups attached to it. So like I said earlier, we have the front carbon. This bromine is in the plane, so it's going to be going straight up. And then we have an ethyl coming out at us on the wedge, and so that's going to go on the right side. And then we have the methyl on the dash behind the page, and that is going to go on the left side. So right side is on a wedge, left side is always on a dash. Step 2 is identifying the back carbon and the three groups attached to it. Same thing, you can see we have this hydrogen in the plane going down, so that is going to be in the plane going down. We have a hydrogen on a wedge, so that's going to be on the right side, and then we have a chlorine on the dash, which is going to go on the left side. And then you simply just superimpose these images together to give you the entire Newman projection. So now we're going to do a little practice. Take a second to pause the video, and then try your best to draw out the entire Newman projection for these three. Alright, so here are the answers, and we're going to go through these. You can see on the front carbon here, if you're looking at it in this direction, it's not a very pretty arrow, but you get the idea. You have a methyl going up, you have a methyl going towards you, and you have a methyl going behind the page. So off of this front carbon here, we're going to have three methyls. And then same thing for the back carbon. You can't see them, but they are going to be three hydrogens on this. One going down, one going towards you, and one going away from you. So the back carbon is going to have all three of these hydrogens. Number 2, here is that front carbon. Coming up in plane with the rest of it is a methyl group. Coming out at us is this ethyl right here. You can see it has 1, 2 carbons. It would be a little bit clearer in a print, but that was the best drawing I could come up with. And then on the back, sorry, not the back carbon, still on the front carbon, but going behind the plane, we also have a methyl. So we have the methyl going up in plane with the page. We have the methyl going on the dash behind the page, which is why it's represented here on the left. And then we have that ethyl coming out at us on the wedge, and that's why it's on the right side. On the back carbon, we have a methyl going down in plane with the page. So we have a methyl coming off of the back carbon down. And then we have two chlorines, one going out at us and one going behind us. So coming off of this back carbon right here, we have chlorine on the right and left. Again, looking at this front carbon right here, we have a methyl going up in plane with the page. So we have a methyl going up here on the Newman. And then we have a bromine coming out at us on the wedge. So that is going to be on the right side. And then we have a hidden hydrogen on the dash behind the page, and that's going to be on the left of the front carbon. Back carbon right here, we have a chlorine that is going behind the page, so that's going to be on the left side of the back carbon. We have a hidden hydrogen on the wedge coming out at us, so that's going to be on the right side of the back carbon. And then we have a methyl in plane with the page on the back carbon, so you're going to have a methyl going down here. This just takes a lot of practice to get. If you have molecule modeling like sticks and balls, you can play with those, and that way you can get a better idea of what this is representing. It helps if you actually make the molecule you're looking at and then rotate it 90 degrees and look at it head on with the front and back carbons in line with each other, and you can actually see what the Newman projection is representing. I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.